This is 1.4, Solving Linear Systems Part 2. So we're going to solve a 3-variable system. This one's actually not going to have a solution, so let's see what happens. So I'm going to label my equations like we did before. This will be A, B, and C. So I'm going to use equations A and B to eliminate, we'll pick X this time. So equation A and equation B. To be able to eliminate X, I'm going to have to multiply equation A by -5. So I'm going to multiply -5 by equation A. So that's -5X plus a -5Y plus a -5Z equals -10. Don't forget to multiply that number also by the -5 because that's a common mistake. Equation B, I'm going to write right below it, 5x plus 5y plus 5z equals 3. I'm going to add those two together. We get -5x plus 5x is 0, -5y plus 5y is 0, -5z plus 5z is 0, so that's nothing's left. And you have -10 plus 3, which is -7. So 0 equals -7 is a false statement. Therefore, we have no solution. Let's look at example 3. So the first one, I'm going to eliminate the x values. Now again, we're going to label our equations so we can talk about them. So I'm going to use equation A and B. And if you notice, the z's are actually opposites, so I don't have to do anything to either one of these. I'm going to add them together. X plus x is 2x. -y plus -y is -2y. Z plus a -z is 0. And -3 plus -3 is a -6. We're going to call that equation D, because that's my next letter. All right, so I need to eliminate Z again from two different equations. So if you notice, I can't use A and B, but I can use B and C. And B and C, the Z's are exactly opposite. So again, I don't have to multiply by anything. So equation B and equation C. X minus Y minus Z is equal to -3. 5x minus 5y plus z is equal to -15. I'm going to add these two. We get 6x minus 6y. -z plus z is 0. The -3 plus a -15 is a -18. And we're going to call this equation E. All right, so we need to use equation D and equation E and eliminate one of those two variables, either x or y. I'm going to eliminate x, so I'm going to take equation D and I'm going to multiply it by -3, so it makes those x's exactly the opposite. And then I'll just take equation E just like it is. So -3 times equation D is -6x plus 6y equals +18. And then I'm going to write equation E, which is 6x minus 6y is equal to -18. And then we're going to add. -6x plus 6x is 0. +6y plus a -6y is 0. And 18 plus -18 is 0. So here we're stuck with the thing is 0 equals 0. It's a true statement. So this indicates that we have an infinite number of solutions. So what happens is these three planes actually intersect each other at a line. So we have actually a solution that's actually a line. All right, let's take a look at a real life problem. An amphitheater charges $75 for each seat in section A, $55 for each seat in section B, and $30 for each lawn seat. There are 3 times as many seats in Section B as in Section A. The revenue from selling all 23,000 seats is $870,000. How many seats are in each section of the amphitheater? So we need to write 3 equations. Like I said, if we have 3 variables, A, B, and then 1, which we'll call that one C. If we have 3 variables, we need 3 equations. So the first one we can do is that if we add up the seats in A, B, and C, then that should give us 23,000 seats. So A plus B plus C should give us our 23,000. Then we have the cost per seat. So Section A charges $75 for A. Section B is $55, so 55B. And C is $30, so $30 times C. And that should give us our total possible revenue, which is $870,000. Now the third equation is a little bit tougher. So it says there are 3 times as many seats in Section B as in Section A. So this equation is actually only going to involve A and B. So there's 3 times as many seats in Section B. So if I take Section B, I know this is equal to 3 times A. Since one of our equations only have 2 variables, we can actually do this entire thing by using substitution, or at least the start of it. So what we're going to do is we are going to take 3A, that's what B equals, and we're going to plug it in to the first equation right there for B. So A plus 3A plus C is equal to 23,000. So that gives us 4A plus C equals 23,000. The second equation with the money, we can plug in 3A again in place of B. So 75A plus 55, and B is actually 3A, so we replace that with 3A plus 30C equals 870,000. So we're going to simplify. 75A plus 165A plus 30C is equal 870,000. Add like terms, we get 240. A plus 30C is equal to 870,000. So that gives us 2 equations with 2 variables. So here's the one equation, and here's the other. So they both have A and C. So we are going to use those 2 equations and eliminate one of the variables. Now, my larger equation, which is the second one, 30C is the smallest number we have. So I'm going to multiply the first equation by -30. And let's label so we don't get confused. So we're going to call this equation A, and this one equation B. So we're going to take -30 times equation A, and then we're just going to take equation B just the way it is. So let's multiply that out. -30 times 4A is a -120A. -30 times C is -30C equals -30 times 23,000, which is -690,000. Then equation B is 240A plus 30C equals 870,000. We'll add those two equations together, and we get 120a, negative 30c plus 30c is 0, and negative 690,000 plus 870,000 is 180,000. Divide both sides by 120. A equals 1,500. Once we have A, we plug that back into one of our formulas. I'm going to choose equation A. So I'm plugging that back in to A, equation A. So 4 times 1,500 plus C is equal to 23,000. And I simplify. 4 times 1,500, 6,000, plus C equals 23,000. Subtract 6,000 from both sides, and we get 17,000. So section C has 17,000 seats. Plug those two back into one of the ones before, probably one of the original ones. Let's look back up here. So we know that A plus B plus C equals 23,000. So we're going to use that first equation. So A is 1,500. I do not know what B is. C is 17,000 equals 23,000. And we simplify. So we can add those numbers together. 18,500 equals 23,000. You'll subtract 18,500. To give you 45,000. Not 1,000, 4,500. So there's your solutions, okay? So section A has 1,500 seats. Section B has 4,500 seats, and section C is the lawn, has 17,000 seats.